Today, we have the honor of presenting the Lifetime Achievement Award to a person and an individual who has truly been a visionary, and he has transformed the world of technology as we know it, and even as we have not envisioned it. What Jensen Huang and his journey has done, and the NVIDIA team has done, is really disrupt the world of AI, enable automated driving solutions, great health tech solutions, machine learning, and even all our day-to-day conversations. I don't need to give this person a huge introduction. We all know who he is. And so I would like to invite Jensen Huang to the stage. And before you clap, we have Navin Chaddha in conversation with Jensen. Navin, as you know, is the man with the Midas touch. He is top 100 on the Forbes VC list. But most importantly, the reason we picked Navin is for him, people come first. And what has inspired me as I've gone through this process of bringing Jensen to the stage is Jensen is a tremendous leader, but most of all, he is so approachable. And his humility and his statement to me back in the green room is, I am here for you guys. I want to make this successful. This speaks to how down to earth he is, and I feel grateful that I've just had these interactions with both Navin and with Jensen. So welcome, and a big round of applause.
Thank you. Thank you. Thank you. You're on this side?
Yeah. So we have a small award for you, Jensen.
Oh,
you
wow.
have many, many awards. On behalf of the South Asian community, we have a small gift for you.
My goodness.
As she announced, the Lifetime Achievement Award for making AI everything, everywhere, anywhere.
Thank you so much.
Yeah.
Thank you. Thank you so much. Thank you. Wow, this is incredible. Thank you. I'm always reluctant to receive these Lifetime Achievement Awards.
Yeah, you're just starting, you told me.
I know, we're still young, you know?
We are.
Okay, thank you very much.
Yeah.
This is a great honor. Thank you. Such a great honor. Thank you.
Great. So welcome, everyone. I've been coming here for a few years, but I think I have the real honor of welcoming Jensen, not only on my behalf, but also on behalf of the people who are in the room, but also the global Indian community. TiE has chapters, as I told you outside, on a worldwide basis, right? So to get started, Jensen and I made sure we didn't send our digital twins. We are real people. Both of us trained our digital twins, but we had a joke that we'll have some special codes that only he and I know, and I just told him right now. So AI can only do so much thing. You can do stuff in real time.
Yeah, but you and I both know a digital twin wouldn't know that they're digital twins.
Yep. And we made sure with
I've never met a digital twin that was aware it wasn't a digital twin.
Yeah, so I think given that this is going to get watched probably by millions of entrepreneurs.
Yeah, first of all, I am really greatly honored to be here. This is such an incredible community, and I've known so many amazing Indian and Asian leaders throughout my years. Many of them have started amazing companies. Many of them lead amazing companies. This is one of the most extraordinary communities that the industries, any industry has ever known. And so it's really a great honor to be here.
No, thank you for your kind words, right? So let's start with your entrepreneurial journey, because entrepreneurs are here, they're budding entrepreneurs, there's new entrepreneurs, people who want to be entrepreneurs and just want to get inspired by your journey, right? And you and I get to talk all the time, right? So tell us, why did you start a company, an NVIDIA? What was the inspiration behind it?
I'm pausing because my own journey is rather mundane. It's not. It wasn't a. I woke up in the morning and there was some amazing idea that came to my mind, or I had the benefit of working with some of the brightest engineers in the world, and two of my good friends, Chris and Curtis, wanted to start a company. And they reached out to me to join them and to be part of it. And that was really the beginning. The question wasn't inspired by some extraordinary event that was happening in the world, or it wasn't like the AI moment right now that caused us to start the company. It just happened that I had two great friends who really wanted me to join their company, and they kept prodding me to join their company, and eventually one of us had to figure out how to go make it happen. And
was that at Denny's where you figured it out, from what I recall?
Yeah, we all have families, and so we needed a place to go hang out just to talk about it. And that Denny's was right outside my house. We were living in East Bay, right off of Berryessa, and there was a Denny's near our house, and so that's where we got together. There are a lot of ways a lot of reasons why people started companies. Ours was not in some. I don't think it's going to go down as one of the most incredible. I don't think they'll make a movie. And so
that's one of my dreams. To make a movie one day, so I'm calling you.
Yeah.
I will make one. People know me, right? Like, that's the thing I need to do next.
I think the best part of our story is that it was ordinary.
But it was authentic.
Yeah, it was ordinary. Yeah, right. It was ordinary people doing ordinary things, observing, trying to solve a problem. We had a particular skill set. We understand a lot about computing. We're very good computer engineers, and we're surrounded by amazing computer scientists. The founders had a lot of great skills. I mean, I don't want to take that away from any of us, but oftentimes I see these entrepreneurs, and they're incredible people. They invented this or discovered that, or our stories. I don't know how to make it sound better.
You're kind.
You know what? If I knew how to make it sound better, I'm going to make up a good story for you guys. But it was 3 engineers. We founded a company, and we pioneered our approach. We had a belief system about accelerated computing, and probably our best story. Maybe if I could pass on just one learning. We believed in what we believed. It was incredibly hard to do. We had to shape and shift and inspire an entire industry to follow us and join us. It took 30 years. That's probably the best part of the story.
So persistence, right?
Persistence, resilience, deep commitment, deep belief, cleverness, and how not to go out of business along the way. You can't be resilient for 30 years. You can't be persistent for 30 years if you're out of business.
Yep.
And
we'll talk about that. We'll talk about that, right?
And so that's probably the best part of the story is not how it started, but how it ended. But I'm hoping this isn't the end. Is this an ending story?
No. It's just starting.
Okay.
Right? Like there'll be a sequel of movies.
Is that right? Okay. He's got this.
You told me we're all young, man.
Thing,
There's not only
talking
this.
about my life as it happened. I have a day's job today. My day is so busy today. I just want to let you know that I'm still starting. I'm still working.
So are all of us, right? Like I have like 16, 17 meetings a day just to keep up with you.
No, that's good. We're still working.
So let's talk about Mayfield, right? Like being in business for 55 years. I was at Stanford when you did the company. Even Mayfield had companies in this space, right? Like 18, 20 graphics companies. And I believe every company needs to have a deep moat, one bet that you believe in as a founder, and go all in. What was that bet you guys made, right? There was S3, 17 other companies, all funded by top-tier VCs. So what was that bet?
That's one way of describing it, and if you don't mind, I'll rephrase exactly what you just phrased. It's important. So we competed against about 110, 120 graphics companies over time, and what made us different was perspective. And some people would say that that's vision, but it's simpler just to say it's perspective. We saw the world differently. So let me give you an example. Whereas people were thinking that they were building computer graphics chips, or they were building computer graphics systems, or they were trying to build the world's best, and you could see it. Their mission statement says, we're going to build the world's best 3D graphics technology. We always saw it as a application problem, that the goal was to make the application richer or more enjoyable or possible in many cases. And the way we express it is accelerated computing. Mm-hmm. The thing that I dropped over time is this word in front of it, which is application acceleration computing. And it's really about the application. We always realized that it wasn't about the 3D graphics chip only. The 3D graphics chip and the architecture underneath and the domain-specific libraries that we invented, OpenGL is, of course, one of them. We didn't invent that, but OpenGL is one of them. We invented cuDNN, which is used for AI. We invented Rapids, which is used cuDF for data processing. We invented cuQuantum for quantum simulation. There's a whole bunch of algorithms, domain-specific libraries that we created over time. But that platform, that library, the chip, is in service of the application. And so we, from the very beginning, instead of just having graphics chip designers, we always had people who were working with the application industry to inspire them to use the technology, to work with them to refactor their applications so they can take advantage of the technology that we invented, or maybe algorithms to make their computer graphics games better. And so we were always in that mix of the intersection between the application and the architecture we created. The scientific computing industry and many industries describe it as co-design. And co-design says that you would develop the applications and the algorithms, the libraries, the systems, the architecture at the same time. And
so an end-to-end perspective, right?
An end-to-end perspective. In fact, AI is a co-design problem. In fact, AI is a full-stack problem.
Yep.
And in 1993, NVIDIA was founded in that very specific way. It is the reason why we were able to invent new computer graphics algorithms and see it adopted by the industry, because we always were working with the game developers, we were always working with scientists, we were working with the ecosystem, because our perspective wasn't to build a great graphics chip. Our perspective was to enable the applications to somehow be better. And that perspective difference manifested in a different type of organization, different type of go-to-market, different way of thinking about developing technology. How you see the world manifests. If you allow your belief system and how you see the world to be manifested in how your organization is created and how technology is created inside your company, it could turn out very differently.
Yeah, and I think I remember when the time you guys were doing this, I happened to be at Microsoft. They had acquired my first company as an entrepreneur, which invented video streaming over the internet. And I learned from Bill Gates, you can only do so much, build an ecosystem. Don't compete just on your own, and there were like thousands of Unix, proprietary systems, and then Jobs got it right the second time when he did the iPhone and the iPad. And I see some similarities here that you're saying it's an end-to-end platform, But I think you guys have done an amazing job of building an ecosystem that when you make money, you're making sure others make money too, right? Is that a good summarization for the broader audience,
Yeah,
right? Like grow the pie.
Yeah. At the core, we're an accelerated computing platform company. And therefore, by definition, it has no use. It has no use unless somebody uses it. And those people are developers. And so developers, the ecosystem, has always been ingrained in our company. And each one, there's no such thing as a single application accelerator, in the sense that you can't come up with one accelerator that accelerates everything. Because if you did, that's called a microprocessor. You know, for what reason would a central processor have such an enormous defect that it can't accelerate all the applications that come its way? And so it doesn't make any sense that you could create one processor to do so. And so we had to create a whole bunch of domain-specific libraries that sit on top of our acceleration platform. And so life sciences, manufacturing, entertainment, of course, video games, of course, artificial intelligence, of course, robotics, self-driving cars. They all have their own domain-specific libraries, data processing, scientific computing, climate tech, ag tech. They all have these DSLs that sit on top of our platform. We have to go create them. And once we create them, we have to help the ecosystem take advantage of it. And if they take advantage of it, they get the benefits of the technology that we've developed, and it all accrues to them. We know now. In the beginning, the reason why people used NVIDIA's accelerated computing is it enabled them to do something they couldn't otherwise do. Today, in fact, almost everything has to be accelerated. And the reason for that is because CPU scaling has really reached the end of the road. And yet, computing demand continues to double almost every year. Unless your CPUs are doubling in performance at the same power or the same cost every year, you're going to have computation inflation. And in fact, we're seeing that. Now, all across the world, people are starting to see computation inflation. And so the thing that we have to do is go refactor the application, accelerate everything we can. Now, one of the applications that we accelerated discovered the extraordinary cost benefits of accelerated computing. In the final analysis, what we do is we drive down the marginal cost of computing by insane amounts over time. If you look at Moore's law, over the course of the last 40 years, in the best 3 decades, it reduced the cost of computing by a factor of 10 every 5 years, 1.5 times every couple of years, right? Or a couple of times every 1.5 years. So 10 times every 5 years, 100 times every 10, in the 15, 10,000, so on and so forth. In the last 10 years, through accelerated computing, we reduced deep learning cost by nearly 1 million times.
Wow.
To the extent that people realized, why don't we have computers go and exhaustively look for patterns and relationships in a large amount of data? In our digital experience, go learn the patterns from that. And that of course led to generative AI, which is I think, if I were I wouldn't be surprised if this entire conference is about startups and entrepreneurs.
Yep, it is.
Taking advantage of the single greatest technology transition that the two of us have ever seen.
Yeah.
Yeah, and so this is quite an extraordinary time, and this is our contribution. Our contribution is by driving down the marginal cost of computing so tremendously that a new way of doing computing has been discovered. First time, literally, in 60 years, right? In 1964, the System 360 introduced central processing units and everything that we know about computing today. And it hasn't really changed until now. And now people realize that accelerated computing is really the path forward.
Great. I think switching gears, right, like having been an entrepreneur myself and having worked with hundreds of entrepreneurs, my belief is one can make a lot of choices in life. You'll get a lot of good choices, but making a great choice is really hard, and you are the master of figuring out how to say no, even get rid of projects that were happening. So how do you get that sixth sense? Like AI, Gen AI, last 18 months. You've been doing it for a long time with accelerated computing, right? 10, 12, right? There was a moment, probably AlexaNet or something, like you said, this is it. So how do you make those bets? Like how do you see that the world is going to go there, or do you look backwards? Hey, if the world is there, what do I do? What should entrepreneurs be thinking? Because most people will come and say, I'm going to topple Google, or I have a competitive product to you, and the meeting is over with me in 5 minutes, right? So how did you do that?
I do it the same way you do it, and I've seen you do it, just reason from first principles. And in the case of deep learning, when I saw it and when I made the attempt to understand it, and I had the benefit of being there quite early, but what I saw was no different than what everybody else saw, the amazing benefits of AlexNet and the impressive results of AlexNet. But the structure of deep learning appeared quite scalable. It was the first time in history that you could see designing, this is the first time in history you could imagine drawing a schematic of software.
True.
No software, you could draw block diagrams of goops and gops and things like that, all these blocks of stuff, but you've never been able to describe the functionality of software by drawing a schematic. The fact that you can draw the schematic says that it's structured. The fact that it's structured, the question is it scalable? Can you make it bigger software, just like chips? Can you make a bigger chip? And would it continue to retain the properties, the desirable properties that it has? If we gave it more compute, if we gave it more data, would we still see better results? This is no different than if we gave it more transistors, if we made the pipelines deeper, if we made it more superscalar, if we had more threads. Are we going to continue to see the desirable properties? For the first time in history, I saw that in software. And the question is what can you learn from data? Well, I think the opposite is probably more, a better way to think about it is what can't you learn from data? And as we sat there and reasoned about it about 15 years ago, we came to the conclusion this is going to completely revolutionize how software is developed.
So that's the bet you made.
And so now you've developed some core belief. And as you know, once you've developed core belief, you're testing your assumptions every day. I test my assumptions every single day. If facts change, your mind should change. And every single day as I tested it in more and more ways, I came to the conclusion with deeper and deeper conviction that this is going to be the way forward. And so that's how you do anything.
Yep, no, that's important, right? Like for the audience, right? Create your own North Star, make a bet, go deep, and just make things happen. At most, what will happen? You tried, doesn't work, pivot, figure something out, right?
Yeah, and of course, there's a lot of skill involved in the sense that it's not about, I believe in something, bet the whole company on it, lose money for 20 years. That last part and the first part don't have to go hand in hand. And the reason for that is because you still have skills involved. You can make money along the way. You could apply the technology in a whole bunch of different use cases along the way. And so it doesn't have to be you could bet the farm, but you don't have to bet your life.
Got it.
No lives needs to be lost in the creation of businesses and creation of a great future.
So I think switching gears, and you and I briefly touched upon it, finally machines understand human language rather than us going into assembly line, then this new language, that. So finally, we can converse with machines in the language we understand. When do you think machines, because you guys are a pioneer, are going to understand the language of nature?
We're all working on it. First, remember that a computer doesn't understand any of those languages. It only understands numbers. And so the question is what can we tokenize? if we can tokenize English into numbers, and those numbers relate to the words that we intend to represent, it will learn it, and so it can learn English, it can learn Japanese and Chinese and French and proteins and chemicals and amino acids, and so it can learn all of that. And if you can have multimodality and maybe your human knowledge encoded into the learning process, you might be able to even learn all of the meanings of those tokens without supervision. And that's the great breakthrough. In the recent years, we've tokenized just about everything, and we've represented almost all information in numbers, and we've discovered multimodality and unsupervised learning. And unsupervised learning allows us to learn from a lot of data, as you know. And as a result of that, we've now discovered ways to cross modalities, which is how do you go from text to image? How do you go from image to text? Image to text is fairly easy, but text to image, text amino acid to proteins, so on and so forth. You can go on and on and on. And what's the difference between sonic patterns, which is speech recognition, versus text to speech? Now that we can do that, if you can do text to speech, why can't you do text to robotics articulation? And so you can now, once you have a general understanding of and intuition maybe of mental model of how AI is working, then all of a sudden the application space starts to grow really, really fast, and that allows you to then figure out, okay, if this is the case and that's possible, how do we make it easier for that industry to take advantage of this technology, which comes up with another DSL, another domain-specific language or domain-specific library, and then you develop another ecosystem, create another industry, more use cases, a whole bunch more startups, so on and so forth.
So I think that's a good call for entrepreneurs not to follow the herd, think where the puck can go and go solve problems which haven't been unsolved, right?
Like reason about something from first principles and try to get some intuition about what the governing dynamics are, and then you extrapolate from there, and all of a sudden, amazing things comes to mind.
And they know where to go. 2484 Sand Hill Road.
Yeah, right.
Advertisement from Mayfield.
Yeah, right.
So let's switch gears, right? Like the world is changing. It used to be fragmented on the server side, on the data centers. Now the hyperscalers are buying the majority of semiconductor systems, the core infrastructure from you and others. But there is a wave of edge AI. My belief is 100 billion IoT devices, sovereignty issues. What's your vision? How does this play out? Today, the biggest data centers in the world can train, they have the money, it's vanity, hundreds of billions, $500 billion of cash, but intelligence, what I call cognition, is going to be everywhere. So where do you think entrepreneurs and you can help them basically make that happen? Edge AI, sovereignty issues, because a lot of people are traveling from other countries here. So I know you've been talking about it, but if we could get literal on where should they start and how can you guys help them?
Yeah, that question is deep in the sense that it's deep and broad, and let's just take it apart a little bit. Sovereign AI, one of the natural resources of a country is its society's data. Historically, we've always looked at the natural resources as what's underneath the earth that belongs to that country. But in the future, in this new world, the data also belongs to the country. And for what reason should the data be exported to another country for it to be refined and then imported back to you for you to then pay a premium on? At some first principle, it doesn't make sense. And so India should, of course, harvest its own natural resources in the form of digital data, its society's data, train its own models, use it internally, and connect it to, let other people connect to it for a service. And so many countries should do that. So that's one layer of thinking about it. Another layer of thinking about it is to take a step back and observe what is happening at an industrial level. You know that the first industrial revolution, steam-powered engines, the production of machinery. The second was the production of something most people couldn't understand. We produced at very high scale electrons, AC power. Most people at the time could not imagine that AC power would be something of so much value and so much social value and industrial value, and therefore industrial revolution. The third industrial revolution, we produced something even within our generation, this is within your lifetime and mine, and a lot of people couldn't understand it. And in fact, there are many companies in Silicon Valley that never saw the value of what I'm about to say in the beginning. That the idea that something that has no weight, no mass, and doesn't come in a box would be valuable. Software. If you remember, the computer industry started from a time where the valuable thing is the computer, is the box, is the system, not the software.
And it changed with what Microsoft did and what you guys did with CUDA, the lock, end-to-end lock.
That's right. And so that last industrial revolution discovered the production of software. And in fact, a whole bunch of jobs are created, software engineers, the whole methodology of developing software, a whole bunch of tools and ecosystems that support the production of software. And now we're in the fourth industrial revolution, and we're producing something that most people at the moment don't understand. And there'll be new factories being created, and we're going to produce intelligence at scale. And so the production of intelligence we now know how to do, how to manufacture it, how to produce it, how to make it better, how to market it, to produce these floating point numbers. We call them tokens.
Yep.
And so these machineries, these AI factories, are completely different than traditional data centers. All the things that we've said just now, talking about accelerated computing, completely still hold. But using that same technology, formulated in a different way, and setting up factories for a different purpose, we now imagine this new industrial revolution producing tokens. Well, where are you going to produce tokens? Where are you going to produce tokens all over the world? And the countries with excess in energy, there are many countries with excess energy. There are many countries with a great deal of renewable energy are going to have a tremendous advantage. You can produce the intelligence away from where you apply the intelligence. And then which now brings me to the edge question. There are two ways to bring AI to the edge. One of them is remote sensing, of course, just to understand what's going on in the physical world. The second, which is even harder to do, much harder to do and much more valuable to do, is called physical AI, which is the AI leaves the digital world and enters the physical world. Mm-hmm. And there, it can't just understand English and the meaning of natural language or digital or digital information. It has to understand physical properties. It has to, and it's in that world, hallucination could result in performing something that's physically harmful. And so we have to make sure that you could see it in self-driving cars, you could see it in robotics. You generalize that basic idea. AIs can't just learn how to generate next token like an image. It has to be physically plausible. It has to obey the laws of physics. And so future AIs will understand the laws of physics like energy conservation and mass conservation and understand invariance and those kind of things. Yeah.
Got it. So I think switching gears, right? Like you talked about intelligence as a service. Having been an entrepreneur, we were just joking. I came up with the terminology let's see whether Gartner adopts it or not, but it's catching fire. Rather than calling intelligence as a service, we said, why not call it cognition as a service? Because IaaS exists, infrastructure as a service for IT, PaaS for developers, SaaS for business users, and this is the way it will deliver. Very similar to intelligence as a service, but let me switch gears. I see if applications which are AI first and digital teammates, digital twins have to be built, they're going to be boring layers which are going to be worth much more, and they always are, than applications, which people don't know, right? I call it the cognitive plumbing layer. One layer of it, which is systems, training, inference, you guys own. The next level up is models. The next level up is the data layer, and then middleware and tooling. Calling it cognitive plumbing. NVIDIA is the dominant company. A lot of questions I posted on LinkedIn. How can NVIDIA help them? Where do you play? You have an inception program, you have a venture program. What would you want to tell the entrepreneurs? Where you are playing, and since you're a platform, where do you want to grow the ecosystem, which you talked about? And if those layers get fixed, of course, applications will get built, and digital twins, digital teammates will get built. So these 4 layers, where are you partnering to enable accelerated computing to get to the next level? And they're both, one of your team members is leading, who works with us, the Inception program. Another team member is leading the venture stuff. How are you going to help entrepreneurs, right?
Yeah, one of the things that we did well was recognizing that on the one hand, AI and accelerated computing in the way that people want to enjoy computing today is in the format of a data center. Whereas hyperscale is about many small microservices sharing, and many users sharing one computing resource. In the future, an AI factory is one giant AI using all of the data center as a resource. And so this way of doing computing is radically different than the past, and so we became a data center company. However, everybody's data center is different, and we had the good wisdom of designing our data centers in such a way that it could be then disaggregated, taken apart, and then integrated into Azure, and integrated into GCP, and integrated into AWS, so that our platform is everywhere. The great achievement of our company is one, of course, pioneering this approach called accelerated computing, but making it available literally everywhere is one of the great things that we've done. And it's very hard to do that in such a way as to enable architecture compatibility and software compatibility throughout. And so we're in every cloud, we're on-prem, we're in PCs, we're everywhere.
Yep.
And so first thing is for a developer is to realize that we have toolkits for you, and you can run your software anywhere. The second is reach out to our developer program. We have a developer program called Inception. We have some 20,000 startups that we're working with around the world. We provide our capabilities to augment yours so that you have superpowers of a very large company. And it could be infrastructure access, it could be technology access. We have lots of engineers that co-develop, co-design algorithms with startups and large companies and startups. And so we're delighted to help you learn about accelerated computing, learn about deep learning, learn about how to train models and deploy models cost effectively across all these clouds. So there are a lot of resources, including of course, go-to-market resources, how to celebrate you at GTC, provide you a platform to tell your story, to partnering with great VCs like Navin and Mayfield to fund your startup, all kinds of different ways.
And we are doing that already, and you guys, people should know Jensen is gracious, right? Not only to help companies, he actually serves food, serves great wine. I was shocked, a person of your pedigree, to be such a great host, right? I'm known to be the same way.
Nobody clears tables better than I do.
I thought it was dishwashers.
Nobody does dishes better than I do. Hey, look, you know.
So core skill set, the deep mode of.
Look, these are life skills. You know,
they help us.
Bussing tables, making dinner, bussing tables, and doing dishes. These are really important life skills.
And I think I've heard from you, right? Like no job is menial. Become the best at it. You'll become the best at everything. Whether you're an athlete, as long as you give it all. Like I believe, right? Like excellence is not being the best. It's about giving your best.
That's right.
And when you do that, just wonders happen, right? Like, let me bring it down to 2 or 3 questions. You've been a pioneer not only in computing, but also in management, right? There is this philosophy, 7 fishes swimming together, 7 is the right reports. Very different, the way you run the company. Why, right? Like, I know, have your own North Star, like any learnings for entrepreneurs? Because board members come, you have too many reports. Like, how many do you have?
I have 60 direct reports.
So again, 10x.
Yeah.
Not 10x, 8 point something.
Yeah. So let's think about that. The reason why organizations were created the way they look is so that militaries can go to war. Information systems are incomplete. Commands don't want to be questioned. A command, you want the general to be far away from the battlefield because you don't want them to see the pain and suffering of the battlefield and to make decisions that are strategic. And you want people who are on the battlefield to not know how the decisions were made so that they could sacrifice their lives, give their lives in for God and country and mission. But that's not our goal. You know, I don't want anybody to die in the field of battle for me. And I need all my employees. And so the way you think about organizations, therefore, should come from first principles. And the question becomes, what is it that this box called a company, what is this organization intended to produce? What is the nature of the product? And what environment is it in? How do you want this box to thrive? Is the environment such that it's fairly stable? Is the environment dynamic? Is it hostile? Is it? What are the conditions of this environment? And what is the maturity of this box? And so you have to think about it from first principles. And what I came to was that information flowing in the company has to be incredibly high because we're in a highly volatile environment. Technology is changing very quickly. If technology is changing by 1 million times every 10 years, we've got to make sure that we're incredibly agile and people are up to speed or understand the nature of the decisions we're making because time matters a lot. And so that's one. Another is to realize that the people that are reporting to the CEO are all really world-class experts. I'm surrounded by amazing people, and they're world-class in their field. They're incredibly talented, and they're excellent managers. They require very little management, and they require very little, if you will, life coaching. They've achieved incredible results themselves. And if that's the case, then the way the CEO manages, if you will, the team surrounding the CEO should be very different than the way that first-level managers manage new college grads. And so to apply the same principles make no sense. And so I just came at it from first principles, and I architected a company with its organization, its people, its organization.
And probably culture, you tell me,
right?
And
culture and the business processes in such a way to produce NVIDIA. It was intended
so very unique again.
Just one thing. It was never. It won't do fried chicken very well, probably, and it won't do. It won't do a whole lot of things. It won't provide healthcare very well, probably, and so there are a whole bunch of things that it won't do very well, probably, but it does this very well.
Got it. So I think my next question is, you have talked about it, right? Like, no company becomes overnight success. There's a lot of ups, there's a lot of downs, but the best leaders have to make tough decisions. So what is the toughest decision you have had to make, one, in your career, and you're glad you make it, right? Because humans, I know this person, I have existing customers. Which one would you say that is? Because that, in my mind, having been on involved with hundreds of companies, that's where founders, CEOs struggle, right? Like, they can't just let go. And you're known for doing that, whether it's an old version of the product or the world is heading there. So which is the biggest one? And this one came in the crowdsourcing, like 50, 100 people want to know, because you need courage, conviction to make that tough decision.
Well, this question for most CEOs is probably easier. In my case, I've been running NVIDIA for 31 years, and I've had to make a lot of decisions, and many of them life-threatening, many of them my own doing, and so it's hard to choose the toughest one. But I would still go back to the one that you were referring to. A long time ago, we started on an architecture that's called forward texture mapping, no Z buffers, no triangles, but curved surfaces. And turns out the right architecture is exactly the backwards: inverse texture mapping, triangles, not curved surfaces, Z buffers versus pre-sorting. And so we selected a palette of technology choices that was in combination exactly wrong. And the fact that most people probably would think, how is it possible that this is such an incompetent company that in the large selection of choices that it actually went out of its way to choose all the wrong answers. It's like getting 0 on an SAT. And the reason for that, as it turned out, we were smart engineers making good decisions in a world that changed really dramatically. And I won't go into the details too much, but not because it's a secret, it's just not that interesting. DRAM, it has something to do with DRAM prices, has something to do with floating point computing, has something to do with the rest of the industry around us, and the state of technology around that time. But anyways, we made a lot of poor choices. Inside the company, there were the question about what to do was quite divided, and you could imagine why, because we dedicated ourselves to realize that technology. And we were really wedded to that technology. I was really wedded to the technology. I really wanted to succeed. When it became clear that it was the wrong answer, you don't want to accept it. You really, really hated accepting it. So and so did I. But the one thing that was helpful to the company was realizing that our company wasn't about those choices. Those technology choices don't define the company. And if you could figure out a way to isolate, to separate the choices that you make versus the purpose of your existence, the purpose of why you're here and what you're ultimately about, it allows you to in fact even criticize your choices rather objectively and without too much of your ego tied up into it. And so that was a very big learning moment for the company and for myself. To be able to make those choices, to realize how to look at decisions made by strategy decisions, technology decisions, any decisions made by the CEO versus what is the purpose of the company. And if the facts changed, if the world changed, then your mind should change. And in fact, the world changed around us. And I would say reasonable people could have come to reasonable decisions even. We might have made the same decisions again. Those were probably the only best decisions we could have made at the time. But when the world changed, you should change as well. And so that was a gut-wrenching decision because we were simply young. The company was young. We were delicate. We were fragile. We were uncertain. We weren't confident. We were all at the very beginning of everything. But I'm really happy that we were still able to go back to first principles and rely on the confidence and the wisdom of the people that were there, and we got the company dislodged from a whole bunch of bad decisions or wrong decisions, not bad decisions, wrong decisions, and then went off to do amazing things.
It's great. Final two questions, right? Like, I get them all the time. Nobody told me, so I'm going to ask them. If you were starting again, what would you tell your younger self as an entrepreneur? Because most of the people who start companies are like first-time entrepreneurs. What would be your advice when you were starting NVIDIA, now that you've played it? What's different? Like, what would you tell yourself?
First, in 31 years, I've learned a lot. And the first thing I would not do is to share all of that with my younger self. That's the first thing I would do, yeah. Just to hold on to it and to share it along the way. And the reason for that is because there's a superpower in ignorance. There's a superpower in not knowing how hard something is. There's a superpower in not believing that something is impossible. That's a superpower. And the more history we have behind us, the more we know, the more we realize how hard something is. And so I love that feeling of thinking, how hard can it be?
So that's what inspires you, right? Like,
all these hard problems we're looking at. My first inclination is, well, how hard can it be? Well, it turns out it's really hard.
always takes longer.
Turns out it's really hard. But I don't think it was helpful to know it then, And so it's kind of like maybe like running a marathon. I've never run a marathon before, but how hard could it be?
That's my favorite quote. Always. Company building is a marathon, it's not a sprint. And I'm not a marathon runner too, but in company building, I am.
How hard could it be? Just put one foot in front of the other. How hard could it be? So if somebody else can do it, we can do it. And so how hard can it be? I think that is probably the superpowers of a startup.
Got it. Last question, right? Like, both of us know you've been doing this company for 30 plus years. I've been doing entrepreneurship plus VC for 30 years. I get asked the question, so I'm going to pass it to you. Why are you still going? I tell them I'm only early 50s. Warren Buffett is going till like late 90s, right? What's driving you, right? Like, because I know life is long, longevity has gone up, but to get up in the morning and have no time and not to have an autobiography, same problem with me. What's getting you going? Like, what's the unfinished business?
I hear other people answer that question. They always sound so smart.
I'm trying to figure out the answer myself, so I'm passing it to you.
They always sound so smart. I don't have anything else to do.
That's a good answer. I need to copy. First time, I won't have my own North Star.
Navin, you're talented, and so you're conflicted. I mean, in your case, you could be a race car F1 driver. You could be a basketball player. You could be a tennis player. You could be an actor.
Really?
You could be all those things. But in my case, it goes. You could be CEO of NVIDIA. That's your option. And then everything else next to that is highly undesirable. And so, but the flip side of it is the job is incredibly fun. There is no other way to say it. It is just the joy of working with amazing people, doing things that frankly we cannot do ourselves. I can't do myself, but manifest, an idea manifested together with some amazing people and watching them make it happen, seeing the company do these superhuman things, make impact on so many industries, built a platform for a whole bunch of other startups, and you and I know many startups that I've had the benefit of knowing through you, and how gracious and how grateful they are for the platform that we created, and to see that and see amazing breakthroughs happening every single day in all these different fields of science, and how can you script that? You can't write a book and say, I wish my life turned out this way, and then go make it happen. This is as close to fiction as it gets.
Yeah, and I think I've heard from you and learned a lot, right? Where you also said when I was at your office with your execs, you need to do the same for the current employees, right? And to hear that, not only the people who worked with you, it's unfinished business, not only in tech world, but that's a noble cause. The people you're getting in, what's the average tenure of the people that started with you? Is it like 18 years, 20 years, the original? Is it higher?
Well, I just sent an email to somebody who last week was their 30th anniversary.
Amazing.
Yeah, it's I'm surrounded by amazing people that And so I hope I didn't dash any of your dreams.
No. So I think I want to.
We're pretty pedestrian people doing what seemingly amazing things, and I think everybody could do this. How hard can it be? And
still trying to figure it out.
You guys are doing amazing things.
Yeah. So I think, as I said at the beginning, right, it's really an honor from the bottom of my heart to be sharing this stage with you.
Thank you.
You're a legend to give us the time to come here. Please join me in thanking Jensen for spending the time with us.
Thank you. Thank you very much. Thank you for the great honor. Thank you.
It's a delight.
And thank you so much. I appreciate that. Thank you so much. Thank you. Thank you.
Let's go this one. Thank you.
Thank you.